This is Math 122, and I'm going to show you how to do some problems from homework number 2. I'm going to show you how to do the problems with the answers on your homework sheet. So we'll start with number 1. Let's make sure we copy the problem down carefully. B to the 4th power times B to the negative 9th power. Alright, now there are two answers given. The first answer given is B to the negative 5th power. And this is what we get by adding the exponents. When we're multiplying like bases, the base in this case is the variable b. All we have to do is add the exponents. And for a quick aside on why, let's think about what happens when we multiply b to the 4th power times, let's choose a different exponent for the other b. Let's go b to the 3rd power. Remember what a base means and an exponent means. The 4 means multiply 4 of the base by itself. So b to the 4th power means b times itself 4 times. B to the 3rd power means b times itself 3 times. 4 b's multiplied, 3 b's multiplied, so it's b to the 7th power. So the shortcut, instead of writing out all those b's, is just to remember when I'm multiplying like bases, I just add the exponents. Well, the same thing applies even if the exponent is negative. So adding the exponents, I get b to the 4 plus negative 9. The negative number is larger than the positive one, so I'm going to end up getting b to the negative 5th power. Now, mathematicians are funny. They don't like negative exponents. So there's a rule for negative exponents that we can move it and lose it. If the negative sign on the exponent, and the base is on the upper level of a fraction, and we can always make any number into a fraction by just putting it over 1. If it's on the upper level of the fraction, the numerator, if you move the base and its exponent to the bottom floor, we lose the negative sign on the exponent. And I like to think about partying. If somebody's got a negative attitude, and in this case B has a negative attitude because he's got a negative exponent, if you're partying with him upstairs, you wish he'd go downstairs because he's no fun. So we're going to send B to the negative 5th power downstairs, and in the process he becomes positive. His exponent becomes positive. Nobody left upstairs, but we can always put a 1 there. So either this answer, b to the negative 5th power, or 1 over b to the 5th power is okay, but we prefer this answer, the answer with the positive exponent. Move it and lose it. I'll give you another quick example. Let's say we have an expression something like this: 2 times a to the 3rd power over, let's make it b to the negative 4. This time the negative partier is downstairs, and well, maybe there's somebody down there with him. How about an a to the 2nd power? Alright, a to the 2nd power is getting sick of b and his negative attitude, so he says go upstairs. And so we're going to send b with his negative exponent upstairs, and we're going to get 2 times a to the 3rd power, and now moving b upstairs, I get b to the positive 4th power. And then a to the 2nd power is still downstairs. Now this one could be simplified more, but we're not going to get into that on this problem. We could simplify these two by subtracting their exponents. And I'll go ahead and do that. If you don't understand it, we'll work on that in another problem. 2 times a to the 3 minus 2. 3a's multiplied up here, 2 down here. 2 on the top will cancel 2 on the bottom, leaving just 1 a to the 1st power left, times b to the 4th power. And that would be the final answer. But what I was getting at more so was what to do with a negative exponent. Move it and lose it.